Welcome back, everybody. This is the first video of the new unit. Our new unit is called Acids and Bases. It is Unit 10. So throughout this unit, you'll see some pretty cool things having to do with acids and bases, how it affects your everyday life. But today we just kind of want to ease into it and intro some of the terms that you'll be seeing this unit. As of right now, there is nothing due tonight. Just make sure you're following the calendar, because the day I'm recording this is not the day that you were watching this. So the calendar has everything that you need to know. Okay, so to intro acids and bases, we have a lovely little story. So enjoy the sounds of the outdoors, the birds chirping, and the very exciting story that's to come. The degree of acidity or alkalinity, basic, is important to organisms. The body must constantly maintain a near neutral pH 7 in the blood and body tissues. To do this, the body produces buffers that can neutralize acids. Acidic and basic conditions in the body occur due to different metabolic chemical reactions taking place throughout the body. So there's a bunch going on here, and let's just start by going over a few questions. So when it says, what does alkalinity mean? That's in the first sentence, and that talks about how basic something is. And again, when we're talking about something being basic, we're talking about pH, not other things. Number 2, what pH must organisms maintain? A near neutral pH. So we're going to talk about what these numbers and what neutral means, but neutral is a pH of 7. What chemicals do the body produce to maintain this neutral pH? If you keep reading, it says the body produces buffers. So, easy one, buffers. And then, what do buffers do to acids in the body? It's talking about how they can neutralize them. So, we're going to talk about how neutralization works later on, but that's just making an acid neutral. Next section. Water is one of the most important molecules in the body. Cells are made mostly of water, and water is required for almost every metabolic reaction in the body. The force of attraction between water and molecules is so strong that the oxygen atom of one molecule can actually remove the hydrogen from another water molecule. This reaction is known as dissociation. This takes place in our cells. Water, H2O, dissociates into H+ and OH- ions. A charged atom, or molecules, is called an ion. The OH ion is called the hydroxide ion, while the H+ ion is called the hydrogen ion. Free H+ ions can react with other water molecules to form H3O+, or hydronium ion. The human body requires a neutral pH for many reasons. One reason cells like a neutral pH is for proteins. Basic or acidic conditions denature proteins, change their shape, so they can no longer work. So, going into these questions, first one is dissociation, and it's mentioned right there, and it's something we talked about in previous units, and that's when something breaks up into its ions. So in the case of water, you have the H+ and the OH-. Next question, an ion is a charged atom or compound. If we're sticking with atoms, a negative ion, just to review, is an anion. Anion looks like the word onion. Onion makes you cry. Crying is negative. And then a positive ion is called a cation. Cats have paws, it's positive. That's your corny joke of the day. Moving forward, name the two ions that form when water dissociates. We get H+, which is the hydrogen ion. This is very important moving on forward. And we get the OH-, which is the hydroxide. Okay, number 8, what's the hydroxide ion? We kind of did that. That's the OH-. Hydrogen ion is H+. Hydronium is H3O+. So you don't need to really memorize this. It is on reference tables in various locations, and we will spend more time on this moving forward. And then number 9, can you find this on the reference table? If you take a second to go look, the answer is yes. Table L has all the bases that you'll be working with that you need to know. And table K has all of the acids that you need to know. Okay, moving forward. Acidity or alkalinity is a measure of the relative amount of H plus and OH ions dissolved in a solution. Neutral solutions have an equal number of H plus and OH ions. Acids have more H3O plus ions, H plus, than OH ions. Acids taste sour and can be corrosive. Digestive fluids in the body are acidic and must be neutralized by buffers. Bases contain more OH ions than H3 plus ions. Bases taste bitter and feel slippery. When an acid is combined with a base, neutralization occurs. The result of neutralization is a salt and water. Neutralization helps return our body pH to neutral. The process of our bodies maintaining a neutral pH so that proteins can work properly without being denatured unfolded is known as homeostasis. Okay, so number 10, we're talking about how do you measure acidity or alkalinity, and that is looking at the H plus and OH minus. So acids, so essentially we can just look at the H plus and OH minus amounts. So that's how pH essentially works, and we're going to talk about this in more detail moving forward. Number 11, what is a neutral solution? Again, that is a pH of 7. And if we're looking in terms of ions, that's you have an equal amount of H3O of OH minus and H plus. Remember, H plus essentially is the same thing as H3O plus. And as the unit goes on, we're going to talk about this in more detail. Number 12, acids have more H3O plus ions and taste sour and can be corrosive. So if you've ever, tasted like vinegar or like lemon juice, those are very, very, very sour, and those are different types of acids. Bases, number 13, contain more OH minus than H3O plus. 14, these are just coming directly from the reading. Digestive fluids are acids in the body and must be neutralized by buffers. 15, bases taste bitter and feel slippery. A lot of the bases that you know in real life are like soaps and detergents, and those are kind of slippery. Okay, 16, when you get what is neutralization, that's when you have an acid and a base, and you want to neutralize that to make a neutral pH, but in the process you get salt and water. So essentially when you add acid and base to make a neutral solution. Okay, 17, what are two things produced by neutralization? Those two things are salt and water. And towards the end of this unit, we'll be working with neutralization reactions and how to actually figure out what salt is being used. And number 18, neutralization keeps our pH at 7, which is neutral. And it's an example of maintaining, if you were in a living environment, this is the answer to almost any question. The lovely homeostasis. So, on that note, that is it for story time and intro to acids and bases. Enjoy the rest of your day.